The rationale behind these critical regions can be explained in a simple manner as follows. We know that the sample mean is a very good representative of the population mean. So, a larger value of the sample mean is an indication of a large population mean and causes the value of the test statistic to be a larger value. That is, a large positive value of the test statistic means that the population mean is larger than the hypothesized value. On the other hand, a small value of the statistic indicates that the population mean is smaller than the hypothesized value. In the case of two-sided alternative, both larger and smaller values of the test statistic favors the alternative hypothesis. Note here that the TINV function gives you the two-tailed critical region. That is, when you put alpha equal to 0.05, what you get is T alpha by 2. So if you want a one-tailed critical region, you must input the probability value equal to 2 times the value of alpha. For example, if you choose alpha equal to 0.05 in a one-tailed test, you have to enter the probability value as 2 into 0.05 equal to 0.1.